In this section of three-dimensional geometry, we will discuss how to find out the foot of the perpendicular from a point on the line. So, the question is, find the foot of the perpendicular from the point P with coordinates alpha, beta, gamma on the line x minus x1 upon a equal to y minus y1 upon b equal to z minus z1 upon c. So x, y, z is the general point on the line. x1, y1, z1 is the point through which the line passes, and a, b, c will be the direction ratios of the line. So now foot of the perpendicular, what is it? So if you are given with the line AB, this is your given line. Point P is your given point with alpha, beta, gamma as the coordinates. You have to find out the foot of the perpendicular. So if you drop a perpendicular from the point P to the line AB, it will intersect AB at point L. So that will be the foot of the perpendicular, and you have to find out the coordinates of the foot of the perpendicular. Now to find out the foot of the perpendicular, find the equation. This is the technique. Find the equation of the perpendicular line, this line, and then find out the intersection point L using condition of perpendicularity. By equation of line, that means you have to find out the direction of this perpendicular line, direction ratios of the line. So we'll find out first the coordinates of point L. Since coordinates of point L is any general point on the line, so write the coordinates of general point L on the given line by equating the equation of line, which is your given equation, to some constant, and let's take it to be lambda. So x minus x1 upon a equal to y minus y1 upon b equal to z minus z1 upon c equal to lambda. So if we equate each ratio equal to lambda, you will have x equal to x1 plus a lambda, y is equal to y1 plus b lambda, and z is equal to z1 plus c lambda. Now our main aim is to find out lambda, since we have to find out L, point L on the line only. So to find out lambda, we use the direction. Find the direction of perpendicular. Perpendicular direction means you have to find out the direction of the perpendicular PL. So PL will be given by final point minus initial point. Now final point is L, with whose coordinates you just find out in the last slide. So it will be x1 plus a lambda, y1 plus b lambda, and z1 plus c lambda. And the initial point is alpha, beta, gamma, which is the coordinates of point P. Now if you subtract it coordinate wise, you will have x1 plus a lambda minus alpha, y1 plus b lambda minus beta, plus z1 plus c lambda minus gamma. Now you will be given all the values here like x1, y1, z1, alpha, beta, gamma, and a, b and c. Just what you have to find out is lambda. So we will be given with all the values except lambda. Now the main aim still remains, which is how to find out lambda. Here PL is perpendicular to AB. So apply condition of perpendicularity. It says dot product of direction ratios will be equal to 0. So direction ratios of PL we just found out in the last slide, which is x1 plus a lambda minus alpha, y1 plus b lambda minus beta, and z1 plus c lambda minus gamma. And direction ratios of AB is given to you, which is your given line, so which is a, b, c. If you find out the dot product, so that will be equal to 0 since the lines are perpendicular. So this will become a times x1 plus a lambda minus alpha, which is your this thing, plus b times y1 plus b lambda minus beta, which is this, plus c times z1 plus c lambda minus gamma, which is this, and equate it to 0. In this way you will find out the value of lambda. Now the foot of the perpendicular. So find lambda using the last equation and substitute the value in the general point of the line AB. So the required foot of the perpendicular is, when we will substitute the value of lambda in the coordinates you found for L, you will have x is equal to x1 plus a lambda. You already know x1, y1, z1, a, b and c. You just have to substitute the value of lambda here. So the coordinates of point L, which is your foot of the perpendicular from the point P to the line AB, is x1 plus a lambda, y1 plus b lambda and z1 plus c lambda. This is your coordinates of the foot of the perpendicular.